Okay, right now. Okay.
Okay, you can start.
Mhm. And now for the next lecture, we have the presence of Dr. Ali Goharian, who was actually a PhD researcher from the Department of Architecture of Tarbiat Modares University. And his expertise includes simulating building performance, such as the lighting, visual thermal comfort, and optimizing energy consumption. Actually, recently he founded a Compu-lyzer Architects Association. Now it's your time, Ali. We are so glad to have you in this.
Thank you. Hello to everyone. Welcome. Thank you, Zahra, for your coordination and cooperation, and also thanks to Bro because of his presentation. I believe that this presentation was very valuable for people who want to do their research in the field of dynamic shading and adaptive dynamic facade, actually. And please let me to share my screen. Okay,
Yes, I
if
have your screen.
my screen has been shared, please let me know.
Yes, yes.
Yeah, everything is fine. And okay. And I have to make full screen, my screen, or it is okay.
No. Please extend your screen. Yeah.
Okay. Thank you. Okay, again, hello to everyone and welcome. This is Ali Goharian. I'm a PhD candidate at Tarbiat Modares University in Iran. And fortunately, I have a fellowship from Poland University of Technology located in Poland. And my focus during recent years was on building performance through computational design or computer aided design, actually. Because I usually deal with software and plugin related to energy assessment. Actually, I can call myself as a computational and analyzer architect. And by the way, as Zahra told, actually we have an association named the Compu-lyzer, and under this association, actually we have a lot of activities related to building performance through computational design and digital fabrication, AI, robotic materials, and any discipline related to computational design. And actually, it's our pleasure to have any collaboration with you in the future, actually. And today, specifically, we're gonna talk about dynamic adaptive facade. And fortunately, this topic is very interesting, and actually it's one of most important trend these days, because it's one of most important interdisciplinary study, and consists of main disciplines such as architectural engineering, electronic, mechatronic, computer science, and any interested people to work on architectural design. And today, actually, in this workshop, specifically, we're gonna talk about kinetic facade, and we wanna develop a model related to kinetic facade. And actually, here I try to prepare some valuable paper that they are very valuable for people who want to do their research and who want to do a study the study about dynamic adaptive facade and also, for example, Shadi Atia Hossein, Dr. Hosseini, and Amir Tabatkani actually could publish some valuable research in field of dynamic adaptive facade, and and they are very recommended if you are interested in this field and if you want to do the research in this field, actually. In general, actually, the facade, if you want to design the facade according to performance base or environment base, actually, you have to consider some main factors such as solar gain control, natural ventilation, daylighting vs artificial lighting. Actually, this factor, I believe that is very important. And actually, in this workshop, we wanna emphasize on this factor. And also view out and heat control and mixture control and noise. However, the mixture control and the noise assessment actually is not very popular rather than other factors. And I don't know why actually many studies have been conducted in field of energy efficiency and related to dynamic and shading and dynamic facade and shading facade, actually. And there is a bad thing, I think, here. If you want to do if you want to study in field of adaptive facade, actually the terminology and classification, because of many studies actually are there in this field, is confusing, actually. For example, we had a lot of different kind of adaptive facades, such as active facade, passive facade, biomimetic facade, kinetic facade, intelligent, interactive, movable, responsive, smart, and switchable. However, Amir Tabatkani and other colleagues actually tried to classify and categorize the different kind of adaptive facade in terms of typology, but I think there is ambiguity and it's very vague and you have to avoid the terminology and classification. If but according to a study, they are important if you want to do the research. But it's very confusing and it's very obvious for any professionals. And first of all, I want to separate adaptive facade to two major parts. Actually, we have two classes, such as conventional class and non-conventional class. However, for example, recognize the non-conventional class is a little bit hard and sophisticated, but if you know the conventional class, actually you can distinguish other type of adaptive facade. For example, lower shade, Venetian blinds, roller shade actually are included conventional class, and others actually be included to non-conventional class. But actually, I think there is an important point here. For example, when we are referring to adaptive facade, non-conventional facade, it doesn't mean actually it's essential we have a dynamic objects. Actually, for example, we have Galat building, and this building is a adaptive facade based on switchable PDLC interlayers based on polymer liquid crystal films. But most of people actually think only non-conventional facade, or when we are referring to adaptive facade and dynamic facade, actually it means there are, for example, the changes in configuration and geometry or something like this. But only this term actually refer to dynamic of being dynamic of facade actually. And here I try to classify in terms of brief explanation about different kind of adaptive facade. And in this workshop, we wanna approach kinetic adaptive facade specifically. And for example, you can know this kind of facade by knowing the complex mechanical system. Actually, it's famous according to complex mechanical system, and it consists of non-conventional and conventional classes. And for example, conventional classes is like viewer and blinds. But in this workshop, we want to emphasize on modeling of the non-conventional adaptive facade, because this is one of most important trend among adaptive dynamic facade. For example, we have active facade or for example passive facade. For example, double skin facade is a kind of dynamic adaptive facade. However, there is no any object to move physically, and everything is fixed. But actually, it's a kind of adaptive facade. And for example, biomimetic approach in adaptive facade is very recommended, I think, because it's very popular according to material science. For example, the BIQ house in Germany actually has been conducted by Algia to reduce and control risk of glare and extremely incident radiation into a space. And actually this type is very popular, especially according to the research. And this is a kinetic facade. For example, the good example of kinetic facade is Al Bahar Tower, and also Arab Wall in Institute in Paris is one of the most famous kinetic adaptive facade. But usually kinetic adaptive facade consider indoor environment and try to control indoor condition in terms of thermal comfort, visual comfort, and reducing cooling load. And most of the time it used for dry and hot area. And for example, inertial facade is responsible for inertial functions, and also we have a smart facade such as fast changing material and thermo bimetal as shape memory, and these are very popular, I think, according to the research. But however, according to the cost, actually is very expensive, and actually it is not available anywhere, because I can remember I tried to prepare some materials in field of thermo metal as a shape memory, but I failed actually, because there was not available to prepare in Iran, especially in abroad. I don't know, but I know this is very expensive. And interactive or media facade, and most of the time it used for indoor and according to aesthetic issues, and this is not our focus in this workshop. And movable facade actually usually try to trace sun position to generate renewable energies, and most of the time actually it disregards the indoor situation, because actually it focuses on on gaining the solar radiation to generate electricity as much as possible. And According to motion strategy, actually we have three major parts. For example, basic transformation. They are very conventional and common for non-conventional adaptive facade in terms of motion strategy. And also more advanced motion strategy is folding structure. As you can see, it used for Al-Bahar Tower. A little bit it's sophisticated according to motion strategy and movement mechanism. And also biomimetic skin actually is one of motion strategies. And the biomimetic skin also, according to the research, actually is very popular because many research have been conducted in this field because it's one of main interdisciplinary study for dynamic adaptive facade and shading because of nature movement you can find in nature actually. And however, according to some physical characteristics, actually the kinetic adaptive facade is one of the most disciplined in the field of mechatronics. However, our focus in this workshop is not included the element of kinetic facade, but a little bit it is complicated. For example, the sensor for adaptive facade can gain the data, and after that it send the data to processor, and after that the processor comment to actuator to change the physical action actually. And also control system is one of most important trend for dynamic shading and dynamic facade. However, it's very complicated and it's very sophisticated according to simulation techniques because control system actually in terms of simulation is very important because early stage design is essential to do the simulation for control input. It is very important if you want to do the research, and there is a lot of gap according to the research control strategies. However, I told this is a little bit sophisticated because the lack of ability of simulation tools, for example, by EMS or energy management system, you can control dynamic adaptive facade. However, it's only assigned for thermal issues, and for example, you cannot set a set point as a feedback in daylight simulation and harvesting daylight efficiency metrics actually. Only and actually it's only EMS only for conventional adaptive facade, and you cannot use it for non-conventional facade. However, there is some study has been conducted in this field, but a little bit sophisticated, and it's actually they try to use some code or some coding or additional plugin to related some software to each other. And performance assessment of adaptive facade, actually, the most of important assessment of adaptive facade are thermal comfort, daylight level, yellow view out, reducing lighting, and energy load. And actually, there is three major different approach to approach the dynamic adaptive facade. The first is measurement in terms of do the experiment or mock-ups, but it is very time consuming, and actually most of the time is very expensive. And it's not very popular in terms of measurement, especially, for example, in Iran, because of the cost, actually. And the second approach is numerical calculation and estimation. And many studies actually we have in the field of numerical calculation for estimating the dynamic adaptive facade. However, it is not popular for architects and designers because of complexity and something like this. And building performance simulation actually is very popular, and we, as an architect and designer, usually prefer to approach to dynamic adaptive facade in terms of building performance simulation, because everywhere are available simulation actually, and it is not time consuming, and it's easier rather than other factors that I mentioned. And this paper actually has been published in Nature Energy journal, and actually it's dynamic photovoltaic building envelopes for adaptive energy and comfort management. Actually, this experiment has been made by Architecture and Building System Department in ETH Zurich, and I believe that this is one of cutting edge typology in different in the field of dynamic kinetic adaptive facade. Because of some points, there are actually it can adjust itself to different solar altitude angles, and for example, the part of the top of part of the adaptive facade can act differently, and the middle of facade actually can adapt to occupants is to have quality of view as much as possible. And this is very important, and this kind of facade actually is very important, and I recommend you to read this paper. And actually it's a state of the art in field of in field of designing, assessment, ideation, and control strategy. And as you can see, the authors actually tried to consider daylighting, view, cooling in three horizontal section, and actually it's good idea. And for example, you can get this as an idea for developing this kind of adaptive facade actually. And on other hand, actually each panel has been covered by photovoltaic to generate electricity, and the motion of adaptive facade actually is prepared by itself. I mean, renewable energy, and this is very valuable, I think. And also, Murtaza Hosseini, according to architectural concept, actually tried to publish some valuable paper, and according to ideation, these are very important. And in this workshop, actually, we're gonna do the model respecting some position and occupants or indoor environment. And these are very valuable paper, and you can read it if you are interested to develop the interactive kinetic facade in terms of assessment and architectural concept actually. because this paper a little bit easier than, for example, if you want to control dynamic, if you want to do the research in field of control, controlling strategies and something like this. These are a little bit, but it's very intelligent, but a little bit, and they are easier. And in this workshop, actually, I have to emphasize on these three factors, three tips. Actually, in this workshop, our main aim is not to instruct the modeling of dynamic shadings or facade. And in fact, our main goal is the type of approach through performance-based analysis to reach a movement mechanism for the dynamic adaptive facade. And this type will consist of many hexagonal aperture with some panels to open and close in fully state and in fully state. And we try to respect both indoor and outdoor environment. Actually, I want to emphasize again, this workshop actually is not do not aim to do the modeling, for example, how we can do the modeling in Grasshopper according to algorithm or something like this. Actually, we're gonna create a model and after that address a problem, and after that in future season actually we want to solve this problem as much as possible. And we wanna create a model like shoebox, and actually our adaptive facade will be applied on sun facing wall. Actually, I mean the facade is exactly facing to the sun, and this facade consists of several many apertures that they have panels to open and close to allow incident light pass to indoor situation regarding indoor condition actually, such as thermal comfort, daylight efficiency, visual comfort, view out with famous indices. And before starting with Grasshopper, I have to mention these three important things. For the kinetic facade follow an interactive adaptive logic in three steps for improving visual comfort and daylight performance for our model. First, making a user field of vision line between the sun and position and occupant position in the office. Actually, most of people try to make intersection between sun position and indoor environment, but these are not accurate in my opinion. Actually, because you are dealing with Rhino Cross and with the software, and actually it is not global dimension only, it's local dimension. And actually we're gonna address this problem, and after that we will get a solution for this. And second is identifying an intersection point between the user field of vision line and the facade surface, and the attraction point as a trigraph parametric decentralized facade aperture logic to reconfigure the facade modular elements. And this presentation is finished, and after 2 or 3 minutes, I will go to run across and Grasshopper environment to do the model. If you want during something, you can, and
Please, if you have a question, please open your camera and microphone. Any question?
And I believe that all participants actually are familiar with by default are familiar with the Grasshopper environment and Rhino-Cross. If you are beginner, you can try some simple algorithm first of all, and after that you can do it. But Zahra, for the exercise and practice, what is your solution for the participant? Actually, I mean, after this session, they can do the exercise or do the their modelings. Yeah.
Yes, they can practice. I want to share the tutorial video with them, and then they can actually see the tutorial video and then practice with them. But this is not the main source of the modeling of their outcomes. This is just practice, and they can see the video tutorial and then practice with them.
Yes. After that, they can practice and exercise and release their files into Telegram channel, and we can respond to their problems and their issues. Okay, let's get started. Okay, as I told you, our facade consists of several aperture like hexagonal aperture. I prefer to use hexagonal aperture, but you can feel free if you want. You can, for example, use circle shape for this. For this, I gonna call a polygon component. And after that, I have to change its plane to its subplane. And by reduce, you can control the reduce, its reduce, for example. So, okay. And by this input segment, you can control the number of segments that you want. For example, 6 segments, it's okay. And I'm gonna fix this location. For this, I'm gonna use the move and in X direction. For example, it's okay to fix in specific coordination and also in Z direction. Okay, I should turn off this. And actually, I'm gonna produce this in horizontal direction by move again in X direction. Instead of integer, I'm gonna use the series component. And by this component, you can control the count of aperture and the step of that. I mean, the distance between each aperture, for example, 12. Okay, and for a step. Okay. And in Z direction, again, I wanna generate these apertures in Z direction. And again, I use the source component, but it must be graphed. Graph, okay. And the count, for example, 5 for count and a step.
Annie, please open, actually turn on the bifocal. I mean, put the bifocal component, because all the people want to see the names of the components. But I think it's so clear.
Yeah, I think because they are very simple. Because they are very simple. For example, with series, you can produce the numbers. These are very, and by default, actually, I suppose the participants a little bit are familiar with Grasshopper, and because there is no enough time to introduce in detail for each component, actually. It's very simple.
No problem. I know it's the problem with the names of each component, because they ask me that please open bifocal, but each name of the actually component is put on the component. Okay, this is the name of series, so you can see series. Yes, it is the question of the begin picker. I think it's solved. It was solved, yeah.
Let me.
Ghazala asked you if could you please actually explain more, because she's not getting familiar with the grasshopper.
You mean the name of each component? How we can show it?
You know, this is another question that the people ask me, that please explain more about the modeling. What are you doing right now?
Yes, actually, okay. I think it's very obvious. We're gonna create a model. We're gonna create a model. First of all, we have to create the aperture according to size and location. And I think everything is clear because it's very simple. It's a facade. It's a simple facade, and after that, we're gonna add some details for producing the dynamic facade.
Yeah.
Okay. And after that, for each hexagonal, I have to make the shape smaller by escape. And by area, actually, I can the center of each aperture. And for example, by factor, you can increase or decrease the size of, for example, 0.8 is okay. And after that, the smaller shape must be pushed a little bit to back, because I wanna create the frame for each aperture. And for this, I use the move component in the right direction. And for example, 50 centimeters is okay for that. And I'm gonna turn off this. And actually, that curves have been created. After in next step, they will love together to create the frame. By this only, I have to use the roof surface, for example, A curve and B curve. I think it's very simple, and all frame for all aperture actually have been created right now. And also, I'm gonna mirror this frame to complete all frame for all aperture. And by mirror, actually, this surface must be inputted to geometry, and the plane is this curve. And all frame has been completed, completed. And in next step, please let me to take my pen. In next step, actually, I wanna create the panel like triangle panel, for example, into the edge aperture like this. Actually, we have 6 panels so that they can open and close in fully state, and in fully closed state and fully open state. For this purpose, actually, I have to extract these points in my algorithm and these points. And after that, only I should create the polyline between 3 points. For these, for these, for these, for these, for this, and for this. And after that, they will open and close by rotation component. For this purpose, only this curve must be exploded to extract segment and vertex. For this purpose, actually, I call explode component, and this curve must be inputted, and all vertex and segment actually has been extracted right now. And I can call the vertex by list item. This is a list item, and you can call any object that you want by calling the index. For example, by this panel, for example, 0 and 1 index I want, and it must be multi-line data. And select these 2 points. And after selecting the central point, actually, I can create a polyline curve. For this purpose, only I should get the area for extracting the central point by this component. And in this algorithm, I have to use the polyline. Only you have to input to these points and the central point to this. By keeping the shift, you can input the central point, and but I think something is wrong. Okay, I got it. Uh, Actually, the cluster of points actually has been ordered in such a way, and it must be uh, carried in it must be created in a group of six, because we have six segments actually. For this only I have to, no, I'm wrong, excuse me. I only You must change it to graph, and because they must be separated. And after that, for polyline component, only you have to change invert or switch on invert move to create to complete this curve as a triangle curve, as you can see. And after that, in next step, it's very easy. Only you have to duplicate this algorithm. For example, we will have six panels, and for this I have to duplicate by six. 1, 2, 3, 4, 5, and 6. And after that, only I have to change its indexes or to select another triangle. As you can see, for example, here we have 0 and 1 as an index. Only I have to change it to 1 and 2 as an index. As you can see, the next polyline has been created as it's clear. And also for this 2 and 3, and 3 and 4, 4, 5, and last is 5 and 6. Okay, as it's clear, all triangle panel actually into the edge aperture has have been created and have been made actually. And in next step, I wanna rotate edge triangle panel. For this, only I have to use the center for the center for each segment. Excuse me. Only I have to select a point as a center of each panel, and after that, for determining axis, actually I have to use a segment for that, and it will be repeated for other segment. For this, I have to use rotation. As you can see, we have a lot of components related to rotation, but I'm gonna use the not this rotate 3D is very okay for this, for such model. Actually, for example, you can input the geometry center for each panel and the axis for each panel as well. And after that, you can determine the angle for rotating your objects. For this, only I have to input all geometry that I created to this by keeping the shift. You can keep the shift button, and you can input your object to geometry. And in next step, you have to select the center for each panel because I wanna the panels actually open and close in this direction. Actually, I have to use this H center for this. Only I have to use a middle component for this curve middle. By this component, actually, you can input the segment and curve, and after that, you can extract the middle in the center of each segment exactly. As you can see, all central point on the H segment actually have been done, and I can input to the center. After in next step, I have to input the accesses for this. Only I should call a list item for selecting my list, and if I check this, actually all segments actually have been separated, and it is not matched with this because I should to create a cluster in group of 6. For this only I have to call index from 0 to 5 to reach 6 segments. For this only I have to input 0, 1, 2, 3, 4, 5, and it must be multi-line data. And as you can see, the cluster has been created actually are 6 or in group of 6, and you can input into the axis. Or to visualize better, please let me to use a boundary surface. Okay. As it's clear, all triangle shape actually have been done right now, and only by this integer you can change the amount of angle, but it must be change or shift to degree because it's radian. For this only I have to change in degrees mode. And as you can see by this integer, you can control the amount of angle for each aperture. Okay, here I think there is a point. I believe that as you can see, whole facade or whole adaptive facade dynamic, our adaptive facade has been created and has been made, but I believe that according to morphology and according to for example configuration, it's like a non-conventional facade. But in my opinion, according to movement mechanism or motion strategies, actually it is not conventional because all aperture can open and state simultaneously or at the same time. It means actually they can control indoor condition in general. For example, if the sun is emitting directly to the this facade, actually, for example, they can act as a fully closed state, and for example, the reduction of cooling load will be occur. But on other hand, actually, daylight efficiency will be decreased, and it is a problem that we want to mention it. For example, the one of the most important challenge for dynamic kinetic adaptive facade, exactly this is this problem actually. Because when you want to control cooling load or you want to improve daylight, improve your thermal comfort, you have to close or adaptive facade actually has to close the apertures and the panels as a shading to improve thermal comfort and cooling load. On the other hand, for example, daylight efficiency will be decreased. It means the electrical load in this case will be decreased because you have to turn on the light and for example the room and the situation of indoor actually will be dark and you have to turn off your artificial light and your energy electrical energy consumption actually will be decreased. For this purpose actually for example, we know the position of sun actually is different in a desired hour. For example, imagine the sun is located here and are facing exactly to this facade. Only, for example, this excuse me, only this part of facade actually is exposed into direct sunbeam or direct sun rays. And for example, this part actually can allow to diffuse light pass to inside to decrease electricity energy consumption actually. And this is a good solution. And actually, many studies have been done in this idea. However, in my opinion, they are true, but they are not accuracy. And we're gonna address this problem in this workshop. And after that, in next session, we're gonna get the solution for this. As a result, I wanna uh, I wanna change the movement strategies, or I wanna change the movement mechanism for each aperture. For example, uh, I wanna cluster each column, for example, each column separately, and they will act differently relative to other column. For this purpose, please let me to visualize for better understanding. I have to use, it is not important, and actually it is not related to directly to our purpose. Only I want to show you. And the curve must be inputted in the grasshopper environment. And I can internalize data, and I can bring this from Rhinographs. And after that, endpoint component to extract and a sort of point for the curve. This is very, very simple, and there is no any need to explain about this component. And for this arc must be used. Arc, this arc is okay. And actually you can input the start point and the end point, and you have to determine the direction, for example, Z direction. The arc actually has been done, and please let me to rotate it by this rotate. and the plane can be gained from this curve, and the angle I have to change. And after that, I wanna produce a point, draw this curve. And for this, I can use evaluate curve. By this component, actually, you can determine a point on a curve that you want, and it must be reparameterized because I wanna input an integer between 0 and 1, not more. For example, okay, as you can see, we have a point can move across our curve. And after that, for visualize better, I can use a sphere for this. Actually, my aim was to generate a point, and also we have point here. For example, the central point I can get from this curve. It's very easy. I can get the area for extracting the from this component. Here, for example, we have the central points, or we have the number of points, several points, and on other hand, we have a point here, and only by making a distance between this point and these points, I can produce the number to input into this angle for my rotation, actually. For example, I can use the distance between this point and this point. And if I check by the panel, I can see I can see actually for each row 12 numbers have been created right now, and as a angles for my aperture. But as you can see, they are very little, and I have to increase to reach my desired angle. For example, the highest angle is 12, and obviously it is not enough, and I have to increase of. For this, only you have to remap this number by remap numbers component. Actually, by this component, you can change the number in your domain, in your desired domain, and you will see number, and the source must be bound from this and this. And for the target, only I have to use construct domain. In this case, my aims is determine the angle for my for example, lowest angle and highest angle for the rotation of these triangles. For this, for example, 20 degrees, actually their angles will be a start from 20 degrees, and for instance to 90 degrees. And if I connect its domain to target. As you can see, my numbers actually divided between 20 degrees to 90 degrees. And because it must be matched for my geometry, only I have to use graph this. Because the geometry actually has been assigned for only column, and I have to generate to 12 column, as you can see. For example, if I input this, okay, it's clear. The dynamic facade and, for example, the rotation between left side and right side are different completely according to this. Imagine this is a sun, for example. This is a sun, but only it's an imagination only, because it is not funny, but only for producer, I think. And for example, by this strategy, many studies actually have been conducted by this strategy to control dynamic adaptive facade by some position. I mean, the hour, for example, the adaptive facade can adapt itself by the time but today, I don't want to instruct the ladybug. In next gen, Zahra will instruct the ladybugs to you, but only I wanna show you that this problem actually is very essential and it is not accuracy. However, it is interested for everyone who want to be professional in this field actually. For this purpose, I have to use SunPass and EPW. Excuse me for this. I have to import EPW file. I don't want to instruct the ladybug, but only I want to show you what Zahra will instruct you in Excision. And location. And I think yes, it has been made. And but it must be small. It must be smaller by its scale because it's very huge. Yeah, as you can see, it's a SunPass according to the location that is extracted from EPW file from this. And for today, actually, I don't want to instruct this, and Zahra will teach you in next session, actually. And for determining the sun position, actually, I use the LB analysis period. It's very simple. You can only determine your date. For example, is for these days is not essential. And the hour, for example, between 9 a.m. to 3 p.m., for example. 9 and 15 per hour. If I check it, my aim was extract the single and for example, I determined the single position for the sun, for example, 3rd March at 9 a.m. And I can input the hour of year output to this input hour of year. And SunPass actually has an essential output like this. I mean, this is a sun position. This is a coordination that will determine the position of sun, but in Rhino cross. For example, if I visualize it, simply is point two. Can input the sun position to this instead of this point actually. I mean here. Okay. But it is not quite accurate, I believe that, because and yes, as I told you, many authors try to have some strategy for adaptive facade, but in my opinion, this is not accurate because it depends on Rhino cross dimension and the Rhino coordination actually. For example, this is a physical coordination in Rhino cross, and actually, according to realistic of some position, it is not true. If I want to prove it, for example, you can see change the scale of some paths, and as you can see, the angle of apertures, the angle of the panels actually are changing. And it's obvious, it's very funny, I think, and it is not accurate because we when we want to do the research, actually, we're gonna to reach the accurate output as much as possible. This is not accurate, and actually, I can show you by. Please let me to show you more about it by LV Skydome. This is not related to this workshop, only for your knowledge. Actually, I want to use this algorithm. And LV benefit sky matrix. And After that, I have to complete this component by the location, temperature, diffuse, direct normal radiation, and diffuse normal radiation. And I can get this output to a sky matrix to create, but it must be, the scale must be very okay, as it's clear, actually, this is a sky dome, and the principle of the software, the software related to simulation, actually try to use this strategy or this principle. And actually, in calculation of the many software related to simulating the daylighting issues or thermal issues, such as, for example, energy loss or especially radiance, they use such a strategy. For example, if they try this technique actually is simplifying the sky dome to several patches, and actually it's a simplification. If I want to input this hour to this, only you can see there is a problem. I told you many researchers and authors actually publish many high quality paper by this strategy, but I think it is not right because the location of the sun path actually they consider is only a point in Rhino Cross or in a software actually environment, that it is not matched with this. Actually, in calculation of daylight simulation and energy issues, actually these patch must be considered in the calculation. If you read this paper, I recommend. It's highly recommended if you want to dive into the daylight simulation techniques in radiance. I recommend you to read this paper because it's very important, and actually the authors the authors tried to introduce the techniques related to daylight simulation as much as possible and in a professional way actually. For example, if you see the daylight coefficient, this is a formula. This formula is for calculating the daylight coefficient, and this is a crucial parameter for harvesting illuminance and, for example, daylight efficient indices. As you can see, the parameters that have been involved in this process, in this formula, it is not a point. Only it's a patch actually. It's a patch. And according to the formula and the explanation, it's very obvious this is not a point. Actually, it is a patch. And as a result, by this reason, actually this strategy is not accurate. But for example, by producing this number, actually you can adapt. Please let me turn off this. By this number, you can adapt, for example, best state related to sun position. Actually, we in this session we address this problem, and in next session we will get the solution, and definitely is optimization for this solution. And however, there is no any study related to this strategy because it's related to my thesis, and this is a part of my thesis actually. And in NextGen, we after Zahra instructions, we will get the solution for this after simulating the daylight performance and energy issues, and also view quality. We will work on this problem. For example, how we can extract the optimal state exactly relative to dispatch or the method of calculation for daylight simulation actually. Uh, okay, I think for this session it's enough, and in next session Zahra will teach you how you can simulate the energy issues and how you can create the thermal zone and the radiance zone for estimating the daylight indices and thermal comfort indices as well. If you please let me to open the chat. Okay, guys, if you have any question, you can write down on the box chat. And Zara, if you have any opinion, you can reveal them about it. Because in NextGen, you have to teach the simulation workflow.
Thank you. Let me. Okay. Now, could you please turn up your your share? And I want to share the PowerPoint, but it's not necessary for me. Okay, guys, thank you so much for joining us on this session. Today I'm gonna actually send you the GH file and actually the tutorial video to all of you. Please practice it well, and if you have any question, please get engaged and solve the problems of any errors. Actually, we are be there for help. And it's important that your daily presence and the expected outcome is so important and necessary for actually getting and obtain for obtaining the certificate. The main goal of the outcomes is that we want to share all of your outcomes as a booklet on the website. So it's important for all of us. And if you have a question for the modeling of grasshopper, you can ask your question in the Telegram groups. And,
okay, I think someone asked, isn't it is necessary to fill the gaps between the hexagonal? Yes, it is essential, and but for decision, it is not essential on for creating the radiance zone and thermal zone. Actually, it is essential, and in next session, Zahra will you, but it's very simple. Only you have to create a curve around the hexagonal, I mean a rectangular curve, and after that you can join the H curve for aperture, and actually the surface will be appeared, I think. And yeah, it is possible to share the GH file in Telegram channel.
Anybody, do you have the Telegram group? I remember that I have sent you the email of joining us on Telegram group, but is there anyone that don't have this link of Telegram group? You can actually send the email if you have not received it. Okay, thank you so much. I don't know, is it necessary to actually ask the guys to open their camera and take another shots or not? Ali. There is no question. Nothing else. Some people want to take a shot again. Thank you. Okay. Let me. And how we can change the. If you actually actually close your sharing window, we can see all of the people. Ali,
What? Please repeat again.
please close your sharing window.
Okay. Please let me to stop. How we can stop?
I think the top of your window is that stop sharing.
Yeah, I can see, but there is
Please click
no
on
any
it.
option to stop.
No, please click on that. This is actually the
I think you can control from your panel. Yeah.
No, I cannot. Yeah.
No, it is.
Yeah.
No, it.
You, now you're loading your whiteboard. Okay.
Okay. It's okay.
Okay. Anybody want to open your camera? Okay. Now we can have a conversation. Please introduce yourself. We want to first of all start with Helena. Helena Bernardo. Please introduce yourself.
I hope you can hear me well. My computer is a bit loud, so maybe you hear the fans on the side. So I'm sorry. Yeah, I'm Milena. Nice to meet you all. It's a pleasure to be here. Thank you for the information that you gave. So I'm an architect, as I think most of us.
Where are you from?
I'm from Portugal.
Okay.
Yeah, so I did my bachelor and master's in FAUP, which is the Porto school. And not long ago, I finished another master's in parametric design and fabrication design. And yeah, I joined this workshop because I really like the sustainable aspects of architecture. And when I saw it in the DigitalFutures Instagram, it was the one that appealed me the most. So thank you so much for bringing it to us.
Thank you so much for joining us. It's our pleasure. And the next one is Ghazale. Ghazale, you want to start?
Yes, hey everyone, nice to meet you.
Nice to meet you too.
Well, thank you. I'm Ghazale, I'm from Iran. I have studied architecture in Tehran University, and I'm really interested in this workshop because I'm really fascinated by sustainability field, and I really like to design buildings that have lower energy consumption in order to help the environment. Great. Thanks for your time and for the information.
Thank you for your speaking. Okay, now Sara Danatian.
Hello everyone, I'm Sarah Dalatian from Iran, Saudi, and it's my pleasure to be here, and thank you for your time.
Thank you for you. And Merdo. Hi, Merdo. She's my little friend. Merdo, do you want to speak? You are in library? Okay, I got it. Okay. And the next one is Begum. Begum?
Hi, everyone. My name is Begum. I'm from Turkey, and no, it's okay. and I did my bachelor in Ankara in Bilkent University, and then I did my master's at London in Architectural Association School of Architecture. That's it from me. Thank you so much for organizing this. Thank you.
Thank you so much for joining us. And then Virak.
Hi, thank you. Thank you so much, Zara and Ali, for the incredible presentation. So my name is Virya from Cambodia. I trained as an architect, but I did my master degrees in history and theory at University of Westminster in London. And I'm currently teaching, actually. And the reason why I've joined this workshop is that I've always been fascinated about parametric design. I wrote some things about it as well, but never had time to dive into the ideas and using of Grasshopper. So this is a very good opportunity for me to explore myself to Grasshoppers and parametric design. And I also want to be sure what is my next phase in my study, because I'm not sure if I want to go into sustainable design or I want to just go into architecture as a design tool rather than just focusing on sustainabilities and stuff like that. Thank you so much. I hope you hear me, because I use my speakers. So.
Yeah. Thank you so much for your explaining. And about the Fatema Mohseni. Hello. Warm welcome.
Hi. Can you hear me?
Hi. Yes. Well,
I'm very happy to be with you guys, and thank you for your nice workshop. I'm from Iran, but currently I'm working in Italy as a sustainable design engineer. I studied my master in Politecnico in Milano. So right now I'm working both in the energy team in my office and in research and development. And in the R&D team, I was exactly working on modeling kinetic facades with Rhino Grasshopper, and then trying different daylight and energy analysis to see how it could work better. So like when I saw the title of the workshop, I was like, wow, it's exactly what I'm doing these days. I'm happy to be with you.
Thank you. And the other people, I think that they don't want actually open the camera, or they are so exhausted about the workshop. I don't know. Okay, if there is nothing else, we can actually finish the workshop, and then the next day I'm actually gonna teach to you the Ladybug tools. And we have actually the presence of Professor Mahdavinejad explain about the daylight and healthy. I'm gonna share with you the schedule for the next day. Okay, I think Mariam was there. If you want to add anything else, Maysam, yeah, please. Yeah, we are waiting for you. Please open your microphone.
Oh, yeah. Hello, thank you for this workshop. It's a great. And my name is Maysam. I know some people might think I am a guy, but yeah. So it's a female name as well. So I just had recently completed my study in Master of Architecture in University of Technology of Sydney. And I do have a study, like an elective subject regarding the grasshopper, and especially the
No. Thank you so much. Yes, I think because of my unstable connection of internet, it is I ran into this problem. But if you have any want to add anything else, we are so pleased to actually hear about it. And if there is nothing else, we can finish the workshop.
Excuse me, can we have access to the presentation files?
Presentation files, I don't know exactly. I'm not sure because it's necessary to actually get the permission of the each instructor. But we actually share the video tutorial and the GHG files to you at the end of the session.
Also, the recorded videos, I don't know where I can get them.
Actually, I think I'm gonna upload all the videos on the Google Drive and then share the links with you.
Okay, thanks.
Yeah. You're welcome. Okay, can we get the recording? Yes, of course. Another thing, yeah. If you let me, I want to finish this session. Thank you so much for joining us. It's our pleasure to have you in this actually workshop. And have a nice day or have a nice night. I don't know you are anywhere of the world, but goodbye. All right.